Hello guys, you're welcome back to my channel. In today's video, we are going to be starting the preparation for Jamb. How can we score high in Jamb physics? With my trick that I'm going to be giving you in each of these topics in a simplified manner, you can easily score 90 above in physics. It is certain that you can score 90 above in physics. Now, we'll be starting today's class with motion. The first thing that we'll be taking a look at is what is motion. Motion is simply the change in position of a body from one point to another. Now, the study of motion is classified into two types, whereby the first type is what we call the kinematic study of motion, and the second one is the dynamic. Now, when we are talking about kinematic, it is the study of motion that does not require the causes of the motion. Simply means the only thing we want to study is how the body is changing, how far is the body moving, in what time is the body getting to a position, at what is the rate of movement of a body. That is what kinematic is all about. But when we talk about dynamic is simply the study of the forces that causes the motion. Now, in today's class, I'll be starting my video with kinematic. Now, what is kinematic in a real sense? Kinematic is the study of an object motion in terms of its displacement, velocity, and acceleration. There are three things that is joined together under kinematic. That means if you want to study motion based on kinematic, we are going to be studying three things. The first thing is the displacement of the body. The second thing is the velocity of the body. You can just rub off this, The second thing is the velocity of the body. Let me try to just remove this off. So we have the velocity of the body. The third thing is the acceleration of the body. All these things makes up the kinematic study of motion. Now let's take a look at the kind of question that you can be asked under kinematic aspect. Now you see in exam question always come under this topic, such as this: how far does this object travel? How fast and in what direction does it moves? What rate does its speed change? That means what rate does its speed change? At what rate does its speed change? All belong to what? Kinematics altogether. But if you are asked a question on this kind, what force causes an object to move the way they move? This is related to dynamic. It is related to dynamic study of motion. So in today's class, we'll be starting with position, distance, and displacement. Then in my next video, we'll take a look at velocity and acceleration. Now let's take a look at position of a body. Now, what do you mean by position? Position is an object relation to a coordinate axis system. What is a coordinate axis system? You see, there are three coordinate axis systems that describe the state, or let me say the position of a body altogether. Now, as is shown in the diagram, we can have this coordinate axis system, whereby I'll be having my x-axis, I'll be having my y-axis, I'll be having my z-axis. Now, each of these coordinate axis systems at an angle of 90 degrees to each other. Let's say they are at right angle to each other. These are the coordinate axis system. Now you see, position of an object can be described in relation to this coordinate axis system, because this coordinate axis system is a fixed axis whereby the meeting point of each axis here is known as the origin. This is my origin altogether. So the distance of the position of every object in space can be related to this. But in your exam, such as your Jamb or WAEC, you will only be given a two-coordinate axis whereby we'll be relating to only the x and the y axis. The z axis can be ignored for you, whereby we'll be talking about only the what two-coordinate axis, whereby if I have a point, let me say I have a position, I have an object that is located at point P here. This object can have a distance relative to the parallel to the y-axis, and it can also have another distance parallel to the x-axis, whereby the two distance of the object, the distance from here to here is taken as my y, while the distance from here to here is taken as my what? X. This my y is known as the ordinates, while my x is known as the abscissa, whereby each of these two values, which they represent the distance of point P from the y-axis and the distance of point P from the x-axis, I can easily put them in a coordinate system of what? S, y. Now, this is what we call position. Now, the next thing is distance. What is distance? For example, now, for you to measure the distance of an object, or let me say the distance of an object in the location that object is found, the distance must be measured with a reference point. As well to know that my reference point here is this, my reference origin, which is the axis, which is the origin here, is my reference point. Every object in space would be measured related to the origin. Let's say from here to here it will represent the distance of the object from the origin. Now, what do you mean by distance? A distance is a scalar that represents the total amount traveled by an object. Total amount traveled by an object. In other way, since there is a scalar quantity, I always refer it as the total length that is being covered when an object moves from one position to another position. Altogether, one thing about distance is that distance depends on the path that is taken by the object. Altogether, because it's a scalar quantity, so it depends on paths. Let's take, for instance, if I have something of this kind here, I have this kind of movement like this. Now, take a look at this. The object is starting from point A and moving to point B. Are we together? We have an object starting from point A and moving to point B. Now, the total distance moved, this is the starting point of the object. This is the finishing point of the object. Point B is the finishing point of the object. Total distance moved is simply the length of this object from this point. No matter where the object is moving, you need to think about how the object is being moved. So the total length of this line from point A here, go like this to point B, that is representing the distance of the object. Distance is simply a scalar quantity. Are we together? Hope we are facing up with this. So it is a scalar quantity in which it does not depend on the direction that is being moved by the object. It's only what anywhere the object takes, that's where we're going to measure the total length from that point to the final point. Now the next quantity we are going to be defining under kinematic now is now the displacement. Displacement. Now, what do we mean by displacement? Let's take what we call displacement. You see, in our basic textbook, we believe that displacement is just an object change in position. The change in position of an object. That is what we call displacement. In some definition, you can just say displacement is the distance moved by an object in a specific direction. Now, if you watch this here, this object from point A to point B here, this movement is not directed to one single position because the object I'm moving, if I take a look at my coordinate axis, I can have y coordinate, x coordinate. Now, if you watch here, on this position here, the object is going along the y coordinate axis. When it's move along the ridge like this, it can go along the s coordinates. In this place here, we also have y coordinates, s coordinates, y coordinates, s coordinates. All together. So the object is traveling along the both coordinate axis at the same time here. Simply means it is moving in different direction. So if I take here as my north direction, my east direction, my south direction, and my west direction, simply means the object is moving in different direction. And displacement is simply the change in position of an object along a specific direction. Now, if this is the initial position of the object, which is taken as your first position, and this is the final position of the object, which is your position B. Now, the displacement of this object is simply along a straight line from point A to point B. Let me try use something that will more differentiate it. From point A here to point B here, this is the displacement of the object. The object moves from point A to point B, altogether along a straight line. So that's why we said displacement is an object change in position. Now, note something that displacement and distance, they are both measured in the same unit as meter. But one thing differentiates the two quantities, distance and displacement, is that displacement is a vector quantity. It has a specific direction, while distance does not have a specific direction. We can measure the distance of an object along different directions, but a displacement of an object can be measured only in a single direction altogether. So in that case, this thing here, now displacement, because it depends on the position of an object in that specific time altogether, in the location of an object, that's what the displacement is all about. It simply shows that displacement can be denoted with a symbol which is change in x. Now, where this change in x simply means change in x, whereby this symbol is known as delta. It can represent change, and this s here represents the spatial location of the object. So change in s can simply mean the final position of the object minus the initial position of the object. The final value of the x minus the initial value of the x. Now, if point A here is having S1, that is the initial position, point B is having S2, which is the final position, the change in x will be equal to x2 minus x1. Why? Now, note something again, that displacement does not depend, does not depend on the paths taken by the object. If you take a look at this from the start, the object is taking this path here to its motion, but when we want to consider the displacement of the object, we only consider the initial position and the final position of the object. Now let's take a look at an example to simplify all this explanation I've been giving to you now. Now, in case you see something of this kind in exam, how can you differentiate between distance and displacement? I've given you that both distance and displacement are measured with the same quantity, the same unit, which is meter, but they have been differentiated that distance only depends on magnitude, and displacement can be described both with magnitude and direction. Altogether, simply means distance is a scalar quantity, while displacement is a vector quantity. Now let's take a look at this example. Now we have an infant cross 5 meter east, then 3 meter north. An infant cross 5 meter, okay, then right, okay. An infant cross 5 meter east, then 3 meter north, then 1 meter east. Now let's take a look at it in a well simplified manner. Then I say we should find the magnitude of the infant's displacement. In this question here, I'm going to be explaining both. I'm going to be finding the distance. At the same time, I'll be looking for the displacement altogether. Now let's take a look at this. Now, I think we have this. It said an infant crossed 5 meter east. If you take a look at your cardinal points, this is my east, this is my north, this is my south, and this is my west. So they said an infant crossed 5 meter east. Now, this is along east. The distance moved by the infant is 5 meter along eastward direction like this. Let me just use it like a little bit big. So we have what? 5 meter east. Now, I said 3 meter north. Simply means, and one thing about the vector, since that this is a vector. Now, a vector is always represented with a line. The stopping point of one vector is the starting point of the other vector. So after it has got, this is the starting point. Now, when it got to 5 meter here, it moved 3 meter north along this direction, 3 meter altogether. Then 1 meter east. Then after that, it goes under what? 1 meter east. This is 1 meter altogether. Now, this is the finishing point of the object here. This is the finishing point. Let me use this to indicate we have the finishing point of the object here. This is the starting point of the object. Now, what is the object displacement? Don't forget I said displacement only depends on the object starting point and the object finishing point. So we can easily get the object displacement by drawing a line to form a triangle. Now, this is the displacement of the object. Let me say this is point A. Now with this example, the vector diagram of the question has been drawn to us, and it said an infant crawls 5 meters east, then 3 meters north, then 1 meter east. Now, if you take a look at your cardinal point that I said earlier on, whereby we have our north direction, our south, our east, and our west direction. So we've been given that the distance along north, if we take a look at the starting point here, this is our starting point X, and the end point of the vector is F. So along this direction to here, from here to here, let me say here is M, we have 5 meters, and then it moves along north 3 meters, then move to the nearest this thing in 1 meter. Now the question is now asking us to calculate for the total displacement of the body. Now the total displacement of this body is simply the distance from point X to point F. Don't forget I said the displacement depends on the initial and the final position of the body. Now, how can we get the final and the total displacement here? I can easily get this total displacement from here to here by considering this thing to complete this triangle. If from here to here is 1, then I can draw something here to show that from this point here I have 1 meter, yeah, and this place from F, let me take this place as point N. So from F to point N I have 1 meter, from M to point N I have 1 meter, which is equivalent to this 1 meter in this place here. So the total distance from X to N is now equals to 6 meter, while the distance from F to N is still remaining 3 meter. Now now we need to find the value. So if you watch here now, at point N here, this thing is a right angle triangle at point N. So I can easily find the distance X to F by calculating the displacement, the total distance. Using a Pythagoras theorem, we can get this total distance SF. Since this SF here is the hypotenuse of a right angle triangle, now why XN and FN are the base. So we can just use the formula for Pythagoras theorem that distance SF into square equals to distance SN into square plus distance FN into square. Now my SF, we don't know it, we need to find out. But what is my SN? My SN is simply 6 meters. My XN is equals to 6 meters. R is equals to 6 meters since from S to M is 5 meters, from M to N is 1 meter. So 1 meter plus 5 meters will give rise to 6 meters. So I'll be having 6 meters here. 6xn is 6 square plus my Fn is equals to 3 square. So this one can easily give rise to 36 plus 9, and 36 plus 9 can easily give rise to 45. Now don't forget that we need SF, but here we have SF square. So my SF, distance SF, will be equals to square root of 45. Now square root of 45 will be giving rise to, I'll be having 6.7 meter. So my total distance, my displacement of S to F is 6.7 meter. That is my displacement from X to F, which is 6.7 meter. Now let me write it very well. 7 meter. Now the next question that he has not given to us, what about if, assuming in this question, we are not only asked to find the displacement, please note, we are not only asked to find the displacement, but we also asked to find the distance that is covered by this body. Now, how do we calculate for the distance covered by this body? The distance covered, don't forget I said the distance that is covered by a body is independent of the parts that is taken by the body. Now, it simply shows that, let me try to use something different so that you can understand. Now, if the body is moving from, if I want to find the distance of the body, then we'll take the distance it takes the body to move from here, from X to M. Then after getting to X, from X to this position here, let me take it as point O, from X to O, then from O back to F. Now, the distance the body took from X to N, so simply means total distance covered by the body. Total distance covered by the body. Total distance will be equals to from X to M. X to M is only 5 meter plus from M to O, which is 3 meter, and then from O to F, which is 1 meter. Simply means total distance that will be covered by the body will be equals to 9 meter. Now, the total distance covered by the body is different from the displacement of the body. This simply shows that what? Distance can only be computed using algebraic method, while displacement can be computed by using triangle law of vector, or let me say, sorry, triangle law of addition to calculate for the displacement of the body from X to F. Now, let's take another example to buttress everything that I've been saying since. What about if I given this equation, this example here? They said, in a track and field event, an athlete runs exactly once around an oval track. That means the athlete runs around this oval track like this. Altogether, then I said a total distance of 100 meters. The total distance covered by this track, let me say, if here is the starting point of the body. Starting point of the body. Now, if here is the starting point of the body, and here is the finish point of the body. Now, if you watch here, now you notice that the start point and the finish point, they are what? They are the same. The start point of the body and the finishing point of the body, they are likely to be equal to what? Each other. That means they have the same point altogether. Now, here, we are now asked to find the displacement of the body, not something. You see, whenever a body is moving along a circular path altogether, now, don't forget that the body will be having the same starting points and the same finishing points altogether. So if the starting point of the body coincides with the finishing point of the body altogether, if we have the starting point and the finishing point coinciding with each other, automatically the displacement of the body will be equals to 0. Why? Because we don't have the initial position and we don't have the final position. And don't forget that we said something later on that displacement depends, it only depends on what? Final and initial, the position of a body. Position of a body. Altogether, since in this question here now, the initial and the final position of the body coincide with each other, automatically the total displacement of the body will be equals to 0. Thanks for watching. Please don't forget to subscribe to my channel and like the video, because your like would really help me to be ranked high on YouTube. You can also share with your friends if there is anything you need explanation on. Please don't forget to drop a comment for me in the comment box section below. I will surely attend to your question one after the other. Thank you.